Hello dear civil engineers. Today we will discuss about very interesting topic of structural engineering related to release in secondary beam or release of partial fixity in secondary beam. In this slide, we will know the definition of secondary beam. What is secondary beam and what are the type of secondary beam that we encounter in our daily life, daily engineering life. In order to define it, it is defined as if either or both ends are connected with beam, then that type of beam are known as secondary beam. Case first. In this case, one end is connected to the beam and other end is connected to the column, and it is shown in this left picture. And in case second, both the ends are connected to the beam, and it is shown in the second and the right picture. And in this slide, we will discuss about the difference between primary and secondary beam. In primary beam, both the ends are connected to the column. That's why both the ends form fixed or rigid connection, which means all the degree of freedom get restricted there. There will be sufficient space available there to provide the development length of beam, and the complete mobilization of tension could be done there. While in case of secondary beam, either or both the ends are connected with the beam, the end that is connected to the beam will not be able to resist rotation, due to which it will not be able to resist or transfer bending moment completely to the supporting end. Most of the cases, there will not be sufficient length available to provide the development length in tension, the result of which it will not be able to completely mobilize the bending moment produced at the joint. Hence, it will not completely behave like a fixed end as we expect it to be. And in the next slide, in this slide, we will try to understand the meaning of end release. I've taken example of simply supported beam and fixed end beam, both loaded with same load W unit load per meter, per running meter. Okay. End release doesn't mean that the bending moment that we release will go out of the structure. Instead, it will be redistributed from the end to the center of the beam. In order to clarify it, let's take an example of fixed end beam and simply supported beam of length L with uniformly distributed load W over it. Both the beam will respond in different way, but the ultimately load they will carry is WL. In the case of fixed support beam, bending moment at mid is WL by 24, WL square 24, and the support it will be WL square by 12. And in case of simply supported beam, there will be no bending moment at support, but at mid it will be WL square by 8. From these two cases, we can clearly understand that if we release the rotation of fixed support, the moment at the end will shift towards the center of it, and it will behave like a simply supported beam. This simple concept of moment redistribution will be applicable in the case of end release. And in this slide, we will discuss why end release in secondary beam is done. It is done when sufficient length is not available there for development length. It will not be able to qualify as a fixed connection. In order to model the actual behavior, we should release the end moment. Second one, bending moment from secondary beam could cause torsion in main beam. To avoid this effect, designer could intentionally release end moment even if there will be sufficient space available for development length. Sometimes the purpose is to avoid the congestion of reinforcement in the primary beam at the intersection of the secondary beam. Fourth one, ends are not restricted against rotation. Moment will not be able to transfer toward the support. In order to idealize this effect of the beam, we need to release the end moment. These are the reasons why we release end moment of the secondary beam while modeling or while calculating, while designing the secondary beam. Thank you everyone for your kind attention. And if you like my presentation, my video, please do like, subscribe, and press the bell icon for more updates. Thank you.